Hi everyone, I'm Vanessa Johnson, and today we're going to explore the idea of what if our GraphQL schemas actually understood accessibility and not just our data. So to do this, we're going to be embedding our UI semantics into our schema. But before we dive in, a little bit about me is that I'm an Android engineer at the New York Times. I've been there about 2 years now, and I work on the Games app. So if you've ever heard of Connections, Wordle, maybe even Pips, that's the team that I work on, and I'm passionate about accessibility. So I know many people may not know that the New York Times has games, but they have a Games app and a cooking app that you can check out. But for this presentation, we're looking at the impact of making accessibility a first-class citizen in API design, and have that work across Android, iOS, and web teams. And then the belief that problematically accessibility metadata can bridge the gap between API design and inclusive user experiences, making the user experience better for everyone. So just a quick agenda. We're going to look at the pain points and accessibility gaps, like within API design, the shift, accessibility in API design, the custom directives. So I'm going to share a GitHub link at the end of the presentation. That's like a sandbox of how all this can work. The schema to the client screen, so for native, so Android or iOS, or maybe your web teams, and CI validation, and then any considerations within your teams or who owns these directives. So let's start off with why this all matters, both for people and for the business side. So about 16% of the world's population has some sort of disability, and about 71% of them leave in the accessible sites immediately. So many times people go to these sites and cannot go and proceed through the website for various reasons. Maybe it's a color contrast between the text and the background, or there are missing accessibility information that apply to the components on the screen, and that information is missing to be given to the screen readers for them to hear audibly what's on the screen. And then with all that to say, there's only about 4% of websites that are fully accessible, and then 96% of them are inaccessible within like the top 1 million websites that they've gone through in this report. Okay, so there is a cost of leaving it that way. There's abandoned flows, lower conversions, and support issues that never quite go away. So that leads to abandonment, and then obviously with abandonment, the users can go to your competitors, and that's a potential loss of revenue. Also with SEO traffic gain, it goes into like discoverability and reach. So whenever someone is searching up for whatever your product or your company is doing, the way that you construct your site can make it more discoverable and bring in more users. So accessibility isn't just about compliance, it's about market expansion and better reputation. Companies that invest in accessibility see measurable returns across customer satisfaction, conversion rates, and operational efficiency. So many times you may have customers that leave reviews and say how good the accessibility is for your site or your product, and then that will lead to more users to come and use your product. So some common web content accessibility guidelines failure types are low color contrast, like what I touched on before, missing alternate text for images. So many times there are images on the site where people can't see. So if it's necessary for them to know what is being depicted in that image, there should be some information that's applied to that image so they know audibly what is on the screen. Missing input labels, empty links, and then any empty buttons. But we're honing on any missing information that needs to be fed to the accessibility tools like TalkBack in Android, VoiceOver for Swift or iOS, and then also for web forms. So those examples show that there's a gap in our APIs, or at least room to shift the accessibility talk left into our features flow. So our APIs shape UX before any UI code exists, but accessibility usually isn't part of that conversation. So APIs define what information is available and how it's organized, and influence UI decisions before designers even start. Many times, accessibility is added late, so you can kind of think of it where there's an architect that's designing a physical building, and on the blueprint, there's walls and ramps. But many times, for like software engineers, putting in that new feature, for accessibility, the infrastructure, in that infrastructure, accessibility is usually treated as the coat of paint that you put on last or just for like finishing touches. So there is an inconsistent implementation. So each team implements accessibility differently, leading to inconsistent experiences across platforms. So depending on if you're on Android or iOS, the developer that implements these, accessibility information or metadata can construct it differently, so that leads to different experiences across platforms. So with those gaps comes with pain points. So there's no single source of truth for accessibility. So there's labels, roles, and descriptions are scattered across client implementations. Client-side string stitching, so to construct these strings, to say, for example, we have lists or components that are grouped together like cards. So many times, depending on the developer, you will construct a string and say that this is the way that it's going to be spoken out to the user. But since, depending on the level of communication between your teams, that they can be scattered or different on different platforms. And then with that, semantics drift across platforms. So like I said, implementations will diverge, and then the user experiences are not the same. So with that in mind, let's look at how constructing the accessibility information on the client side it looks like. So right here, this is like an Android example, but say if we have like a list of movies, and we have like a title, a rating, and a release year. So you construct the string that's going to be applied to a content description. So that's just the accessibility label that's applied to a component. And then when you are using a screen reader that can step through your app, then that's the information that's going to be spoken out to the user. So stitching like this for 3 different platforms, you can think of it as you're giving 3 different chefs, for example, the ingredients, and hoping that they all cook the same meal, but it might not turn out the same, especially if you don't have like a standardized recipe. So brittle and duplicated, so string concatenation breaks when fields change, and logic is duplicated across Android, iOS, and web. Phrasing varies by developer, and then the key insight here is that the pattern can become unmanageable as your UI changes or your data changes. So say, for example, you make some UI changes that either shows more information or shows less information, then you'd have to modify this string on all platforms instead of having it being done in one place. So seeing that, the core claim is that we embed our semantics into our schema. So starting off, we have a type movie with the 3 pieces of data that I stated before, and then there's going to be a way that we can apply additional information to say that we're going to get this single source truth template and apply it to our components. So for web, it's the ARIA attributes. Android is composed semantics. For iOS, it's the accessibility modifiers. And then we're going to look at some CI validation to see how we can enforce this earlier on in your workflow. So schema as a contract, the schema defines semantic requirements, not just your data shape. Client agnostic, so the web and mobile maps to their native semantics. And then, like I said, CI enforcement. So we're going to have validations to catch regressions early, so you can run whatever script locally and within like your CI workflow. So if you use like GitHub Actions, for example, you should be able to catch those when you push up your code. So since you're approaching this with directives, there are a few attributes we should keep in mind. So we want something minimal, only what clients must agree on, no bloat, no unnecessary complexity. Additive, so enrich existing schema, don't replace it, and then have some backward compatibility just in case things don't go as planned. Stable, so durable names that survive refactors and schema changes. Client agnostic is not tied to a specific platform. And then non-breaking, so safe defaults for existing customers, gradual adoption. So say, for example, you are querying for that accessibility object, you have some safeguard on the client side to fulfill that accessibility information or metadata if it's not retrievable from the server. So these principles ensure the directive set is practical, maintainable, and scalable across teams. So like I said before, I have a sandbox on GitHub with the approach, but we're going to look at the small directive set that is used on that GitHub. So here we have accessibility label. So it defines the label as like a default or primary identity for the component for your screen reader. You have the role, so it defines any semantic role, so it could be a group, a button, a link, or an image, so depending on your use case. The template is where you can have some human readable sentence, so it's more, it's better in a way for the user to hear it in a specific ordering for your string instead of just hearing each component individually. For like when you're stepping through your row, for example, and you have multiple pieces of data, instead of having to transverse each data piece in that row, you have a summary of what is being shown. And then for the accessibility token, it maps a field to a token for you using your template, but it's also another way for you to increase flexibility and provide more information. So say if you have a prefix or a suffix that I'll show in further slides. So going into a little bit more detail on each of these directives, for the accessibility label, what it does is that it tells the screen reader is the primary field or like the default. So say for a movie example, it would just have the name of the movie instead of having all the extra information, depending on if that's what you want, if that's the experience you want your users to have. Why it matters, it provides the main identifier, and it is announced first when the user encounters this object. Usage pattern is applied to the object type, not individual fields, and imports to the field that best represents the object. Next is the accessibility token, which lets you mark important pieces of information. So you can incorporate a data type and field name. This token can represent a price, a rating, a date, or depending on what extra information you need to be incorporated into that string. That is specific or like an extra piece of information for the field that you apply this directive on. Order of importance, so you can have the priority from the third attribute. You can have lower values where the default is 0, and then that will be the ordering of how it is in your template. For prefix and suffixes, you can format numbers with currency symbols, percentages, and unit labels. So you can have the $sign, ratio, or some type of extra symbols that you need to display your information. Numbers, this is dependent on what screen reader you use, but sometimes 299 can be spoken out as 299, so you can treat values as a Boolean and make sure it's spoken out as the whole number. And for the accessibility template, this is going to be the human readable part that we can tie all the pieces together. So we can use the field name syntax to refer to schema fields in the template. And then this is the natural language, so it kind of treats the information that you are compiling to a human readable sentence that the screen reader can speak naturally. Dynamic assembly, so obviously with the GraphQL, you can query for what you want and don't get what you don't want. So when you are querying for the information, so say for like title, release year, and rating, then all of that information will be in your sentence. But say if you only query for one, the other parts will not be in there. So that reduces like any latency or time that would really reduce any time that the resolver takes to compute the sentence. So here's like a complete example of how the schema could look like. So you have like your type, and you apply your sentence on the object, and then you have the label and token applied per attribute inside of your type. So you don't have to use all of these. It depends on what your use case is, but this is just a way for you to apply some more information, have more flexibility. So within here, you have like a name and a price. Like say if you had a list of items that you're purchasing for like a shopping cart, then you can have the type of it is a price, the prefix is a $sign. So kind of constructing this in one place and then have it apply to every other platform. So, and then on the right side, we have our type, accessibility, the token, and the templates. So you use what you see fit for your use case. Looking at a concrete example and keeping in the movie example we had. So we have the type movie, the role, which is a group, since we're grouping all of the components in the row for that specific movie. The template, we have all of the attributes that are available, but then obviously it won't be there if it's not queried for. And then the label and token is us applying your default, and the token is the flexibility that you want. This is only half of the type, since I couldn't fit everything on the screen to make it legible, but this is the first half. And then the second half is just applying it to the rating, and then the accessibility object that you can create for at the bottom. So here we have the label, defines like the primary identity. The role is a structural meaning, so it depends on how it's interpreted, so if it's a card or something else. And then the template plus the tokens equals the descriptive output. So it uses the tokens to build your accessibility descriptions. So to make this all possible, we have to wire up our schema in a specific way. So you can start off with your directives, have a GraphQL schema built, and then within your resolver, you can have a plugin that uses the AST to scan your schema to say if this label is present or not, and then if it is, then it will build out the accessibility object for you. And then in the response that you get, you have the accessibility information. So here we have an example of a query. So here we're querying for all of the movies. On the right, I just show one element in the response, just for space purposes. But here we apply query for the accessibility object, and we get the components that we wanted, so the label and the templates, and the template includes everything that we queried for. So this is us in runtime in action. So I ran a Apollo just sandbox, and I just showed that the query and then what the data looks like on the right. I think it's probably a little hard to see on the projector, but it just shows that there's 3 elements or 3 movies and has like their specific information and the sentences that were made based on what you queried for. And here I'm just showing the alternative. So say if I queried for less information, then only what I queried for is in the summary. So let's see how this works on Android and iOS and web. So here we have a composable. So this is just how we create our UI on Android. And we have a movie card and a row. So we apply the summary that we get from an API call that we store in a movie object. So we get the summary, apply it to the row, and then that is the description or the summary of the text in that row. And then if you have any images, you can also include that there, but depending on if you want the user to know what the image is showing, then that's up to you to incorporate that into the summary as well. So key features that you use the generated summary field just through the API dot annotation, and then the direct semantic mapping from API, and it's consistent with your schema definition. And the benefits is that the screen readers get meaningful hints. There's no manual string building needed natively, and then it's platform agnostic. So assuming that every platform makes the same query, you should be able to get the same summary. So here, this information will be spoken from TalkBack, since that's for Android. And then for Swift, it's the same idea. We have the same schema, same semantics. It's just expressed with voiceover. So for here, it's same logic where you have your H stack, which is just a row, the way that the data is oriented on the screen. So we have the summary that we get applied to the accessibility label, and that is going to be spoken when the person has that component in focus. So the Swift UI automatically uses the summary for the voiceover announcements, and it provides consistent accessibility across all Apple platforms. Lastly, for web, it's same idea, just showing it that it can be done in web as well, where we have our React components can consume accessibility metadata directly through our area labels. And then same thing, we use the summary that we get from the API call of the movie object and apply it to the group. So how can we enforce or better keep our schema in a desired state of having this embedded information? So we can run checks on our schema. So here, this is also in the GitHub, but you can run a script to make sure that you have the specific directives in mind. So here it fails because in the example, I removed the sentence and I have the accessibility template as a required directive. So here, as in a backend engineer, since you're probably going to be the ones fixing up your schema, and you push it up, so you'd have to have some level of communication with either someone that's in charge of this or have a collaborative effort where you decide like, hey, what should be the sentence for this object, for this type. Okay, so this is showing that after adding it back, the checks pass. So at the bottom, I don't know if it's hard to see on here too, but accessibility contract checked pass for the movie type for the movies. So that will be dependent on what your types are, or if you have a larger database of types. So you have some validation rules. So in the first three, labels, role, and template are required. The token, you can be marked as optional, since it's just another way to you to add a flexibility to attribute. But you have a failure message, so you know exactly what needs to be added. You have a fix, and then you want all your tests to pass and have your schema coverage be as high as possible. So with the CI integration, you can run it on your PRs or locally. Locally is probably easier for you to catch them earlier on in your workflow. It validates your schema, it checks for the accessibility directives, and it fails on missing labels. So these are the functions that check for each of the directives and for the type. So like I said, you use the abstract syntax tree to make sure that those directives are present in your schema. So incremental adoption strategy. So to start small, you can begin with the 5 to 10 critical screens. So maybe like checkout flow or anything like that that prohibits the user to commit some type of action. So you want to identify those key screens, prioritize that flow, and focus on repeated elements. So maybe, like I said, rows, lists, cards, anything that has the same type of structures multiple times on your screen. Prioritize patterns, focused on repeated, like I said, rows, cards, reusable components. So you want to also establish a glossary, so that's more within documentation. So create a shared naming convention, define your token names, document patterns, team alignment, and then assigning ownership, like who do you reach out to for whatever labels are missing or accessibility information that's not coming through. You need semantic ownership, and then like within your review process, like what dictates a good sentence over something else. So that's more manual testing and accessibility testing with the tools that you have. So, and then for owner for that could be your team lead or like a collection of people on one specific team, or if you have a working group. So considerations and final thoughts, like who owns these directives? Consider establishing a functional team. That probably won't be like the next step if this is something new for you, but you can have maybe a UI, product, and backend to come together and decide what the user experience should be from the API level. Because usually we would hope that the API stuff is done first, but if it's done alongside, that's probably a little bit easier to say like, hey, this is not coming through how I want it to come through, and then being able to have that manual testing to say like, this doesn't sound right, this is what should be done here or have here. What happens when metadata is missing? So implement some graceful default when the client side doesn't get the object, say if it's null, for example. So you need some type of fallback. And then for localization, you can probably feed localized templates per locale, or maybe you want to keep it how you are doing it already if you are supporting more than one language. So we want to make accessibility within your server-driven contract and not an afterthought, so you can embed it into your schema as an option. So same thing with the localization. It could be a server-side injection or a template, but for versioning compatibility, you can use feature flags to gradually implement this or test it out. Backward compatibility for new directives are optional. So since these are custom directives, it's up to you what you include and what you don't include. And then schema evolution, so you add new metadata fields without breaking changes. Thank you. So that's all for this. I left some time for questions, and then if you want to find me outside of the times, that's my portfolio, LinkedIn, and the GitHub. And then I will push up some changes to the GitHub to have more of the CI validation stuff so you can test it out. But thank you. Yes.
Thank you for the presentation. I have a question. So, from the title of the talk, you actually want to inject the UI semantics into the API. So, and from what we have seen, in the API, we define how stuff would look. For example, something might be a button or something.
Wait, Q? Like raise, yeah,
Oh, sorry. And you expose the semantics of the UI into the API. And there's a school of thought that says, yeah, you need to separate your model or your API from how you present it, like the key concept behind the MVC. So what's your comment on, since you are injecting the semantics of the UI, how do you address the fact that maybe something that you expose and you have defined in a specific way in the API, maybe in some application or a different application would want to show differently, and now you have injected it in a specific way in the API. How would you handle the situation?
All right, so if you are, so say for example, we have like Android and iOS where we have a consistent UI and they are the same, so it would work a lot better for that. But say if you do have some variability of what you want to be spoken out, like depending on the data, or how, are you talking about like the data that's presented or like the configuration of the screens?
Maybe you want to have a quite different UI than what
Okay.
you have designed in your API.
So can you give me an example? Like say if we had like a movie and we had, so are you saying that in the data we have all the information but we don't want to show all the information, or are we showing more information?
Maybe in one app, what you intend for the movie would be a button, and in another app, it would be only a label.
You can use the role. So I think with servant-driven UI, we are telling the client like the architecture of like the layout of the screen. But if you use like roles, you can say like this is a group, this is a label, this is a button for that case. But then also if like say if you are only showing specific data on one place and less or more on one other place, you can use I think it's called token hydration, where you can have like tokens coming down with like priority and what the information is, and still construct it on the client side. So it's still like flexibility, like in between, where you're still getting like what it should be said, but kind of having it more in a dynamic sense where this works for this place. I don't know if that answers your question.
Thank you. A very good presentation. Thank you very much. What I wanted to ask is, do you have any tools?
Can you speak a little louder? Sorry.
Oh, okay.
Yeah,
Okay. Thank you for your presentation. It was really good. What I wanted to ask is, do you have any tools or websites to recommend for us to testing our websites, the accessibility or the screen readers to listen what are going the people with disabilities or have some issues to listen? How do we test them?
So for accessibility tools, so for like say for Android, it's called TalkBack. I think it's built in on Androids. For iOS, it's called VoiceOver. And then for web, I'm forgetting the specific tools, but you can like look into DQ or DEQ. It's like DEQE. That's a good source that you can like test out any accessibility problems. And then for Android, there's something called accessibility scanner, where it kind of tells you like, hey, this component is missing a label, this component is missing this. So so that's more automatic. But then when you do flag those earlier on, like issues, still do the manual testing, because it can Like automation can only do so much. Like it's better to like step through it and say like, okay, I'm in this person's shoes. Like what is missing from this screen? Like if I made the screen completely black, could I go to the next page? Could I still do what I needed to do to as I wanted to on the site? Thank you.